Hello, today I'm going to be going over my 4.2 math unit lesson, 4.2 being the unit calculus of functions of two variables, and I'm going to be going over 4 different kinds of problems. The first problem I'm going to go over is f of x and y equals negative 3x to the 6th minus 2xy to the 5th plus 5y to the 3rd, and we have to find f of x and f of y. So I've already written it down on my whiteboard. We're going to start with f of x. So we're going to take the derivative of this first variable, which will be negative 3 times 6, and will give us negative 18. We're going to subtract 1 from this exponent, which will leave us with 5. Now with this one, since there's two variables, we will only be taking the derivative of the negative 2x. And since there's no exponent, it'll just be negative 2. And we're going to leave the y alone, so it'll be y to the 5th. And we're not going to be taking the derivative of this one because it is not applicable. So that is our answer for f of x. Now we're going to take f of y. So again, we're not going to be taking this one because it is not applicable. Now we're going to do, for this one, we're going to leave the negative 2x and put multiplication sign right there and take the derivative of y to the 5th, which will be 5y, and then 5 minus 1 is 4. And then we're going to take the derivative of the 5y to the 3rd, which will be 15y squared. Now to finish solving this out, we will have a negative 10x, x will come first, y to the 4th, plus 15y squared. And that's our first problem done. For our second equation, we have to take the first partial of 5e to the power of 4xy. And I've already have it written down here on my whiteboard again. So this equation is going to call for u sub since we have the e. So we're going to make this part our u. So that's going to equal 5e to the u. So we're going to write our u down here, which is going to be equal to 4xy. We're going to take the derivative. So we will only be taking the derivative of 4x, which will leave us with 4y. Now that we have that solved out, we're going to have to plug it back into our equation. So it'll be equal to 5e 4xy times 4y. Now to multiply this out, you will have 20. 4 times 5, y, since those multiply together, to the e, with e, to the power of 4xy. And that is our answer. For our third equation, we have given f x of y equals 4x to the 4th minus 5xy to the 3rd plus 2y squared. Find the following numerical values: f of x at 4,3 and f of y at 4,3. Although this is very similar to our first equation, it is going to be different because after we take f of x and f of y, we have to plug in the coordinate. So here I have the equation, and we're going to start with taking f of x. We're going to have 4 times 4, 16x, 4 minus 1 is going to be 3. Here we're going to take the derivative of negative 5x, that will leave us with negative 5. Adding y to the 3rd, and we'll now be taking the derivative of 2y squared. Now, for our second step, we're going to be plugging in the coordinate 4, 3. So we're going to have 16 from parentheses to the power of 3 minus 5 parentheses 3 to the power of 3. Here I'm going to plug it into my calculator. Power of 3 minus 5, 3 to the power of 3. And we're going to get the number 889. Now we're going to be taking f of y. So then we're going to start here because we're not going to take the derivative right here. So we're going to have f negative 5x times 3y squared plus, we're going to do 2 times 2, 4, 2 minus 1 will just be 1, so it'll be 4y. Same thing, we're going to be plugging in the coordinate. Oh, sorry, what's the step? We're going to be first multiplying out this part. So it will be negative 15x y squared plus 4y. Now it is time to plug in the coordinate. Y, move this up a little bit, and it will be negative 15, 4, 3 squared plus 4, 3. And I will also be plugging it in to my calculator once again. So it will be, negative 15, 4, 3 squared plus 4, 3. That's going to leave us with negative 528. And that is our solution. For our fourth equation, we have consider the Cobb-Douglas production function P L of k equals 22L to the power of 0.6 k to the power of 0.4. And we have to find the marginal productivity of labor and marginal productivity of capital functions. I have my equation right here. We're going to start finding P of L. So to start out, we're going to do 22 times 0.6 L. So we're going to do 1 minus 0.6, which gives us negative 0.4. So we're going to have negative 0.4 k 0.4. We're going to multiply the 22 times 0.6. So here we have 22 times 0.6 at 13.2. 13.2 L negative 0.4 k 0.4. Now to get rid of the negative exponent, we're going to move it down to the bottom. So that will leave us with 13.2 k to the power of 0.4 over L to the power of 0.4. Now I have to find P of k. So we will do a similar process. We are going to do 22 times 0.4. We're going to leave L alone in this part, but we are going to subtract 0.4 from 1, which will give us negative 0.6. So k will be at the power of negative 0.6. We will multiply this out, so it will leave us with 22 times 0.4. That gives us 8.8 L 0.6 k negative 0.6. And again, to get rid of the negative exponent, we're going to move that down to the bottom. So we will be left with 8.8 L to the power of 0.6 over k to the power of 0.6. And that is the equation overall.